So we'll be having the session on how does internet work, and in that we'll be discussing about the internet infrastructure, which includes the protocols and everything, and the functioning basically on how the data is sent, how it's processed and everything. And for that, we have two vibrant speakers. First, Mr. Srinivas Chendi, or as we dearly call Sunny. He's a senior advisor, policy and community development at South Asia Liaison Officer, and he's also an active member of the APNIC. Very welcome to you, sir. And next we have Ms. Shradha Pandey, who is a fellow alumni, and she's also an APNIC 52 alumni and a very active IG youth member. So I wholeheartedly invite you both to take the session.
Hi. Okay. So I hope you can see my screen. Can you just confirm it once?
Yes.
Okay, wonderful. Thank you. I will go into the presentation mode. And before the presentation begins, I would like to express my warmest thanks to Sunny for allowing me to lead on this presentation. And he's there in the background. So if you have any serious question, any serious doubt that you want answered, you can totally ask him. And I'm loving the enthusiasm. I attended the last few minutes of previous Amrita's session, and it was great. I'm loving your questions. So if you have anything that you want to ask about the internet governance journey, my internet governance journey, because I was exactly where you are a year ago. So from there, coming to here, it's been a wonderful experience. So if you want to ask me anything about that, you can put that as well. And I would like to begin about telling you why we need to understand the introduction to core internet technologies and APNIC policy development process. So what we're talking about today is these four aspects. The first is the history of internet. Second is how the internet works. Third is the core technologies, and fourth is the activity. So the history of internet is very important because most of the people that use internet don't really know where it came from. So they don't understand how the internet evolved, and it's very important for you to know that, to see what the ideas were in the initial stages, because it developed as a form of defense communication. That was the reason, right? It was for the Department of Defense of the United States. But later, the evolution today has reached a certain location where the values are changing, where the reasons for using the internet changing. So which is why we have to work and we have to continue to understand and evolve the process. So it's very important for you to understand the reason why this came into existence in the first place. So first, initially, it was called as the Arpanet. And Arpanet was developed by the US Department of Defense Research Project. And research projects, as you know, are either given to think tanks or organizations, or they're given to universities. So that is exactly what happened here. So while there was one connection with defense, proper defense authorities and defense locations, most of the communication, the initial development started between universities. So first internet message happened between two computers on 29th October 1969 between two universities, that is University of California in Los Angeles in LA and the Stanford Research Institute. So there's a very nice story behind what they were going to do and what ended up happening. So they had to, like, University of California had to send a message saying login, LOGIN. But what happened was that they managed to send only the first two alphabets. So only the L and O were sent to SRI. Ultimately, like, the whole thing could not be delivered, and only login LO was delivered. So now, like, people kind of, like, you know, we keep hoping one small step for a man and one large step for mankind kind of sentence. So now this login has kind of changed to lo and behold, when we say, like, oh my God, look, the great thing has happened. But this backstory is that it was supposed to be login and not lo and behold. So that's the first thing that I want you to remember. And the next is internet backbone and how internet evolved and developed. So the connection you initially started between four universities. So it was between University of California in Los Angeles. It was the Stanford Research Institute, the University of Utah, and the University of California in Santa Barbara. So early internet, the earliest form of internet, had only very basic, very minimal features. And they were things such as the telnet, which was like two internets connected amongst each other. And there was file transfer, very minimal size, minimal, like most basic form. There was email, and then there were news groups called the Usenet. So that is what the very initial version of the internet was. Then we come to the birth of the TCP IP protocol. So protocols, in like the most simplest of terms, we'll study more about protocols in the internet technologies. There are slides, we'll explain them in detail. But in the most simplest of terms, they are like rules and regulations. Like if we both are communicating, your rules and my rules for communication should be the same. You cannot have different standards, different rules, and I cannot have different rules, because then there'll be no communication at all. So those most fundamental instructions are kind of what we refer to as protocols. So in 1822, we had the network control protocol. The Arpanet map that you see in here is the 1972 map. And this map had 64 nodes. So now the 64 nodes that you see are what we have, what they each of them had was 4 hosts. So each node, each point that you see there, it could have only 4 hosts or 4 servers it could have. So in those 64 locations, because there were only 4 servers allowed in one location, so 64 into 4, there were only 256 locations that were available in the first version. So what happened was that they decided and they understood the implications of having this on a large scale. That is when the TCP IP protocol comes in. And this is called as the birth of internet. And Vince Cerf, the person who designed this protocol, is called as the father of internet. And one pro tip that I can give you is, if you remain in the internet governance realm, and if you keep attending webinars and conferences, one or the other conference, you will run into Vince Cerf. And he is an amazing personality, and you should listen to him one time, at least from his experience about how they developed, how internet was evolved, and why they felt the necessity of giving birth to a new protocol which was necessary for communication. So that is one of the best developments that happened in the initial stages. And the TCP IP protocol was standardized in 1982. So later, the computers were prepared for a switch from the previous network control protocol to the new TCP IP protocol. And the first TCP IP packet was sent on 1st January 1983. Now, before you get confused, when we use the word packet in the field of internet governance, we refer to information packets. So these are a bunch of information that is sent in the form of packets. So packet nothing here means nothing but information and information packets. So now we come to the core of the session. This is Introduction to Core Internet Technologies, which is how the internet works. So we have a phone, we have a car, we have a machine, we have a laptop, and we have an aeroplane. So how do all of these work? So phone works and the car works through a mobile network, and through proper machines and through proper supercomputers and huge computers, they work through a copper or a fiber network. And then we have the satellite or the wireless network. Now the satellite and the wireless network, all these different types of networks are connected through the core internet technologies. Like the core things are there, the 3 circles you see in the middle, these are the core internet backbone. They're the same for all of them, but they evolve into different type of technologies and different type of internet access points in the later stage. So here what you see is IP addresses or recognizable patterns of all of these different devices. So a particular device for you to use needs to have a recognizable pattern. Like the laptop that you use is different from mine because we both have different IP addresses for each of our devices. So that is kind of how a recognition of your device and the differentiation of your device is made on this field. And the core internet technologies. So now what are the core internet technologies? There are 3 things that are very important for internet to function successfully. And what are these core things? First is the internet protocol. Sorry, let's go back. Yeah, first is the internet protocol. And the internet protocol, what is the internet protocol? I will explain you it next. Second is the routing, and third is the domain names. Now, domain names is something you might be a little more familiar with because you use them, like www.google.com. So that's something like a domain name, like the word google.com is a domain name. So these are something a little more popular, but internet protocol and routing, especially for those who are not in the cyber security realm or who are not studying cyber law or cyber technologies, these will be really new concepts. So we've tried to simplify them as much as we can But if there's at any point you feel like you need a clarification, you need more information, you can drop a message on the chat or you can ask them in the question and answer. So the Internet Protocol or the IP was designed by Vince Cerf and Bob Kahn in 1981. So before I explain what Internet Protocol is, I want to give you another tip. So the information that is shared on these slides, especially about the Internet Protocol designing, the TCP IP protocols, if you keep participating in the Internet governance realm, what happens is that most of the time they have these fun quizzes on Menti or Kahoot. And usually the price for that is Amazon gift cards. So this is the kind of information that you should be looking out for. They'll ask you who was it along with Bob Kahn who designed the Internet Protocol. So at that time, people who are newly there or who don't know about it, you'll obviously be above them because you know it was Vince Cerf and stuff like that. So this is just like a tip that I recognized really early in my IG exposure, and it helped me out a lot. So I wanted to share it with you guys because you should probably use it in the future if you continue engaging with internet governance. So Internet Protocol was designed by these two personalities, and what they did was they laid down a well-known set of rules and standards, and they had them devices on the numbers in this the TCP IP protocol. They identified them by numbers, and the number would not be like a really small number or like number one, number two. It would be a string of numbers that would be unique to your device, and mine would be unique to my device. That's the kind of example that I showed you previously on the screen, where each device, for example, the aeroplane was labeled something, 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 7, 8, 9, 6, 5, 4, and the phone was labeled 1, 2, 3, 8, 7, 6, 9, 10, 11, whatever. 11 would be 1 and a 1. So this is what the unique numbers look like. There'll be a string of numbers. They help identify your device. So how the Internet Protocol works in the most simplistic form is that the data is sent over the internet in discrete packets. You see people packing them as 14, 15, 16 in the picture. So what they do is that they collect the data, they break it into small parts, put them in particular boxes and create packets. And these packets are sent from the source to the destination. And each source and destination on the internet must have an IP address. So these are the three factors you have to remember about how the information is transmitted on the internet. And APNIC is working on creating a game, and it's called the IPGo game. We are currently working on the working stage. It will be rolled out sometime next year. And that game is supposed to be a virtual version. If this was in person, we would explain, we would give you like information packets, we would ask you to participate and share it amongst each other, find out where the information packet has to go. But the same thing is going to come in the virtual field in a much more entertaining manner. So be on the lookout for that. That is one thing that you can definitely be excited about for the next year in the internet governance realms development. Yeah, so internet protocols look something like this. So this is the first part, the picture that you see is the IPv4 version. And the second one is the IPv6 version. Now in the IPv4 version, you have only numbers, and those numbers are dotted decimal notations. And these decimal notations, each of them could be converted into binary 0 and 1 version. And each byte would have 8 bits. So in each byte, you would have 8 bits leading to a proper of 4 bytes in a particular thing. So that leads to 4 into 8 and 32 bits. So what happened with the IPv4 version was that there were only 4.3 billion possible addresses. And with the way the internet boomed, once people started getting access to the internet, and the common people like you and me, we started using the internet, the number of people who wanted different devices and the internet protocols, IPv4 versions addresses, the number boomed, leading to the fact that people knew that they were going to run out of IPv4 addresses once, at least at some point. So what they did was that they evolved the IPv6 version. On the right side, you see the IPv6 version, it has 128 bits. Since each bit has each 8 of each bits constituted into 1 byte, it has 16 bytes, and they have a hexadecimal notation. So if you look carefully, in addition to the numbers, you also see alphabets. So what they did was ultimately they could of course be converted into binary notations, but they extended the number of possibilities that were available to be allotted to the people. So now currently we have 340 undecillion possible addresses. So we are not going to run out of IPv6 addresses anytime soon. But you need to know one thing about the IPv4 addresses, IPv4 version, and that is IPv4 versions ran out very recently. The last IPv4 version was allotted exactly almost 1 year ago. It was on 25th November 2019 that the last one was allotted, and IPv4 version was officially put to an end. And it was said that no more IPv4 addresses can be allotted anymore. So it's not a very, how usually in schools and stuff, we study about things that happened hundreds of years ago and later we try to see it as history. Now, history here is something that was created last year. So this is the kind of the fast-paced nature of internet development that has been going on. That's why you need to stay updated about all of this to make sure that you can participate and help in the future for the development of such new technologies and for the development of internet governance, laws and policies, etc. So autonomous number system, Sunny, you're on the call, right? I would like to bring you in here to explain a little more about the autonomous system numbers, the ASNs, if it's possible.
I'm here, Shradha, and I'm speechless. I'm totally speechless. You did so well. I mean, this is the first time you're presenting these slides. You're inducted into APNIC. Really. I think you can continue on. This is, I think AS numbers, right? You attended the sessions. Keep going. I'll just sit here and listen to you. I'm learning something new as well.
I really want you to explain this one slide because I'm sure I understand it, but I want them to get the exact information.
No, definitely. You're doing really great. Everyone who are listening to Shradha, this is the first time she's presenting these slides. And I made a proposal to the organizing committee to have someone else help me co-present this session, and Shradha kindly accepted to volunteer to be co-presented with me because this is the grassroots level topics, right? Everyone should know. We all use internet. We all should know, how it started and what we use and how the communication happens on the internet. So yeah, I'm completely speechless here, sitting and listening to you, and I can see you did a bit of research as well to prepare yourself. Really great going, and I really encourage you to keep doing this in future events as well. And I hope others will take your lead and come forward to take on some sessions, at least as a co-presenter, if not a full-fledged presenter. And as Ahita said, in the beginning, the Youth Internet Governance Forum was created for the capacity building in India, right? And this is exactly, you can see capacity building in action now. Passing on the knowledge, from experts to, the youngsters and the youth is taking over. So yeah, thanks, Shradha. And I'll do whatever you ask me to do, but you are the leader. You are the main speaker here. So I just want to make one correction to what Shradha said just before about IPv4 last delegation. The RARs are still delegating IPv4 addresses, not in big chunks, but in small chunks, small allocation delegations. But what Shradha was referring there was the last IPv4 delegation from IANA to the RARs that finished. The IANA doesn't have a, well, technically the IANA also have few few addresses still, because some companies, they close and they return their address space. So there are some little address space left with IANA that can delegate to RARs, but not much. But that was a right way of saying that what Shradha mentioned. So let's go back to the previous slide, Shradha, the AS numbers. Yeah. So the AS numbers, autonomous system numbers, are quite important. This is also a protocol, internet protocol. So there's 3 internet protocols in terms of numbers. That's IPv4, IPv6, and the other one we don't really hear much about when we talk about internet is the autonomous system numbers, because these numbers are primarily meant for internet service providers or those who operate networks, those who make us connect to the internet. They have to communicate between themselves as well, right? So in the earlier slide, you saw the cloud and all the devices connecting, and then there's a red numbers with red color, right? Those are the autonomous system numbers. And you saw the image looking like a wheel. Looking like a wheel, those three in the wheel that interconnected with each other. And then you see those autonomous system numbers between them. So this is a good slide to explain this concept. Between the devices is like mobile phone, computers, between the devices, we use IP address. There's either IPv4 or IPv6, but between the routers, those circular ones, they're called routers, and they're primarily deployed by the internet service providers or the network operators. And the communication between them happens through the autonomous system numbers. So if I use an analogy of what autonomous system numbers is, we all very familiar with snail mail, right? Before the internet started, we used to send postcards to each other, and we still do in a way. At least our parents or grandparents, they still do. If not us, we are probably sending our birthday invitation, wedding invitation through WhatsApp now. But they still do. And if you remember, or if you know how we write an address on a postcard, the last set of address in a postcard or on a postcard is a PIN code, right? And this is exactly the same thing. It's a PIN code for router, to identify a router, where it is. Is it in Australia? Is it in US? Is it in India? Where is that router? So this AS number acts like a PIN code or postcode. So if you just remember that, whenever someone say autonomous system numbers, you should just think, oh, it's like a postcode, to identify a router. So when the communications happens from a device to the other device, in this case, let's take the mobile phone to the laptop on the other side. The mobile phone sends the traffic or packet that Shradha was referring, information, to the tower. In this case, because it's connected, it's a mobile phone, it's connected to a mobile tower, and it goes to the tower, and from the tower, it goes to the router of that operator. So the tower could be Bharti Airtel or Reliance Jio, right? And they have their own network. Within the network, they have the router, and that goes to the router, and the IP address stays there, within that router, that identifies who is the user connected to that router. And then the communication then flows to the other routers with AS numbers. But IP address is still in there, to identify who that information is coming from. But then it goes to the router, in this case, AS24478, and then that router says, yes, this IP address is with me, connected to me. I'll pass that information to this laptop here. Okay, so I think that's enough to explain that AS number. Do you want to continue? Unless, please feel free to ask questions. I really enjoyed the session before this one, Anupam's and Amrita's. I hope all the sessions are like that, very interactive, engaging, So jump in, ask questions in the chat. I'm watching it, or raise your hand and ask question. Are you okay to Shradha from here to take over? Yeah, cool. Thank you.
Yeah, Sunny, thank you so much for explaining it. And every time I listen to him, I have to take down notes, because there's some new aspect or new example that is simplified in this version than the previous version. So I have to write all of this down so I can remember it for the next time. So that's how internet governance is, right? So when you participate, there's something new you're going to hear every time. Even if it's a presentation that you've heard of or you've seen somewhere else, there's going to be someone who will bring in their perspective from their country. And that's what's beautiful about the internet. You get to meet people from all over the world, and you get to share what their experiences are in their countries, and analyze what the best policies from there you can implement in your countries, in your localities, and see how they work. So now, before we come to the final, before we come to this part, I want you to understand what the proper procedure is for a policy to take place, or where do these IP addresses and standards come from. So there is something called as the Internet Engineering Task Force. And this task force is the ultimate highest level of standard making body. So they set standards for what the IPv4 standard should be like, what the IPv6 standard should be like, what the allotment should be like. So the example that Sunny told about the allotment. So the IETF standards, the IANA allocations, these are the standard allotment bodies. Like they allot these in bulk, for example, to the regional internet registries, and they later allot it to the ISPs who give it to the consumers like you and me. So now there's a very nice thing that you should know about the Internet Engineering Task Force. Like you must have heard how the bills in the parliament, in the Indian parliament, are passed, right? So the speaker asks, all in the favor of the bill say aye. So then the majority, or if people want to make sure that the bill passes, they all say aye, aye, aye. And then if they says all who are not in favor say no. So then there's no, no, no. So the speaker says, okay, the ayes have it, let the ayes have it, the bill is passed. So what happens in the Internet Engineering Task Force, similar to that, is that they have this concept called the hum. So all in the favor have to say hum. So the entire room looks like a room full of bees and everyone's saying hum. So that is how the Internet Engineering Task Force passes its work, and the majority really takes up their decisions and everything. So that's one entertaining fact that you have to know about IETF. And it's really funny. Sometimes when you're in a big room, like they make students actually do it, like a part of people to actually hum. And it's one of the best things you can participate on when they're doing an IP activity. Next is the Internet Assigned Numbers Authority, the IANA authority, who give it to regional internet registries. Now regional internet registries is the part where you have to pay most interest, because this is the part where you can actually contribute at the most like direct level. So your contributions can be heard by people in the highest authority. So for example, a regional internet registries is where Sunny is working. So if there's an idea that you want to put forward, like a policy development or some idea that you want to put forward, this is the part where you tell it to Sunny, and he has the power to make it actually go to a level where it is discussed amongst like the highest people in authority. That's the problem that we have with our generation, right? We have great ideas, but we're not able to make sure that they reach the highest level where they can be implemented. And this is where the bridge is created, and that gap is bridged. And that is very important, because the participation here is what will evolve into policies in the future. So I'll show you an example of what the regional internet registries look like. So the RIPE regional internet registry is for the North America, APNIC is for Africa. Now the one that you must be most concerned with is, the RIPE is for Russia and Europe. The ARIN is for the US. The one that you should be most concerned with is the APNIC. APNIC is for you and me, for us to participate in. And APNIC is where you can actually participate. So like there is APNIC Fellowship. So after this fellowship, you can actually apply to that. It's a great fellowship. They have some of the most technical concepts are explained in such a simplified manner that even if you are from a cyber background or you're not, it's very easy for you to understand and for you to take hold and participate in the policy development processes, give your contributions, listen to people who are coming from different regions and bringing their ideas. So this is what it looks like, the APNIC platform where you and I can participate and we can actually contribute. So in South Asia, we have India, we have Afghanistan, Bangladesh, Bhutan, British Indian Ocean Territory, Maldives, Nepal, Pakistan, and Sri Lanka. So we have other countries like Brunei, Australia, from where Sunny is joining us today. But the countries that we are focusing on, like in and around India, the Indian aspect of like bringing in our ideas, our viewpoints, this is the RIR that you must be on the lookout for. And yeah, the internet registry structure is such that each of these are members, and they sort of have a higher authority above them called the Internet Assigned Numbers Authority. So if you have like any other doubts regarding this, regarding the structure, if you want any more clarifications, further information, the best person you can ask right now is Sunny. So do not let him go without asking him hundreds of questions, because he can clear each and every doubt, because he's working in these organizations. Like you get first-hand experience learning from him. Yeah, this is one thing that I want to talk about. It's the APNIC policy development process. Now, the policy development process usually happens in all organizations, in almost all organizations, though now the structure is changing. But usually what happens is that a highest authority or the government makes the policy, implements on us, we follow the policy, later we see, oh my god, this is such a good policy, or oh my god, this is such a bad policy. We give that feedback and they later evolve it or change it according to how we reply to them and give our feedback. Now, the difference here is that it's a bottoms up process. So I tell APNIC that these are the requirements, like IPv4 is not working out, we need more addresses, more people are demanding for it. APNIC listens to us and APNIC frames the policy based on our suggestions. So it's a bottoms up process. We give our suggestions and then the policy is framed. And again, when the policy is framed, you and I can actually contribute. They give it open for like hearing public comments, to see what people are saying, to see what people actually want, whether this policy is implementable or not. So all these processes is where anyone can participate, regardless of any restrictions. You can just participate, give your suggestions, give your comments, say if something is not agreeable to you. If you think something's great, you can tell them that. And it proposes an like later there's like a proper procedure for them to accept it or reject it or put it on hold for a little while, and then later the policy is processed and it's accepted. But all the decisions again and policies are documented and they're freely available to anyone. So you can just type on Google like APNIC policies and you can see like sections of policies which are under consideration, which are already implemented, which will be implemented in the future, which were implemented in the past. So you can always find out whether like there's some policy that you think is good or think is not good, and how you can help change it or how you can help evolve it. So that is the best way we can actually make a difference in this field. So this is where I'll be ending my presentation. And from Introduction to Core Internet Technologies Routing, Sunny will be taking it up. Thank you so much.
Thank you, Shradha. Thank you so much. Take a break and have a glass of water, maybe. That was good. That was good. So yeah, Shradha mentioned about the PDP, APNIC policy development process. That's where I put it in the chat. Since we are in an internet governance session, if you want to see internet governance of internet numbers in action, you join APNIC conference, and it's open to everyone. And anyone can participate. And as Shradha already mentioned, and she's our alumni. You can apply for fellowship as well if you want to come to the APNIC conference. These days it's happening online, but hopefully we'll go back to physical mode. You can come and witness the internet governance of internet numbers at APNIC conference. Shradha, the slides stop. Should I share mine, or
yeah,
I can share actually?
Yeah, it's better if you share like the pace.
Yeah, sure. No worries. That's okay. Give me a second, guys. And I hope you can see the slides. Cool. Yes. Thank you. Yeah, routing. So I was mentioning about routing, when different ISPs or operators communicate between themselves, they use the routers, right? So the routing happens over the routers. So let's look at that a bit in depth. So the routing refers to the processing of taking a packet from a user and sending it to the other user, okay? We can use devices these days, the correct term to use here is device actually. The packet is traveling from a device to a device. It's not from a human being to a human being. So that's the correct terminology to use here. The routing process is usually performed by the routers, and if you go to Europe, they say routers, but it's the same, routers or routers, it's all. And what triggers the router to send that packet is the user. People like us, we're using the devices, we send something over, want to send something over across to other person, and that's when it happens. So the content actually, is stored on the remote device. We have the content on our device, or the web servers have the content on their server, on their systems, that you go and access to the web. And the packet travels between internet service providers. It doesn't come straight from the web server to me or to you. It actually takes multiple hops. And you probably would wonder, how many hops it takes, if you want to see that in action. You can actually, these days, there's a lot of tools that you and I can use as well over the internet. So if you want to go to a trace route, it's called trace route. Put it in Google, and you find a trace route website, and just type in a domain name, www.apnic.net, and you can see how many iterations or how many network operators or how many routers is going through till it reaches the final destination. So this is a very simple example of what I just said. In this case, we have, because of the screen limitation, we have only a few devices here, but the internet started evolving. We used to say internet for all, right? In the beginning when internet started, but internet for everyone, internet for all. Now it's internet for every device, that we bring in to connect to the internet, because we started to use multiple devices. I'm on my laptop here, my phone is next to me, my iPad is sitting here, all connect to the internet. So it's actually internet for everything these days, not everyone, not all, but everything that you bring in that needs to connect. And if you walk into a warehouse, or if you walk into a shipbuilding or shipyard, there's multiple devices that connects to internet there and talks to each other, machine language, they talk to each other, they send information across to each other. And that's called artificial intelligence or robotics, So in this example, the routing is happening from the devices using the IP number, either IPv4 number or IPv6 number, through the router, through various means of connection methods here, that you see the wired connections, the black color ones, the wired terrestrial cables, you see, mobile, satellite connections, because these days you can also access internet on the flights as well, and they're connected to the satellites, and satellites are actually increasing these days to provide internet to everyone or to everything. Now, how do the routing packets send? The routing is actually very, have its own language to use, which is Broader Gateway Protocol, BGP in short. Like TCP IP, this is a BGP, so TCP IP, BGP goes along with each other. TCP IP happens between the devices to the router, and between the routers, the BGP takes over. And it's a way of them to communicate that information of sending the packets across. So in this example, a small example here, you see backbone network AS1, it's connected to AS2 and AS3, and AS2 autonomous system numbers, AS means, or providers, connected to customers at various locations. Okay, that's a very simple one here, but you can take this image, and you can multiply it many hundred times, and that's how today's internet is. It's every device is connected to everything, and as Anupam rightly said, it's no one controls it. And that's how it started. The internet doesn't control, no one controls the internet. It just everyone brings in their device and plugs it in, and there you go. You added one more device to the internet, and no one controlled you to connect that device to the internet. No one said you have to meet a certain regulation or certain standards there. As long as you follow the IETF standards of connecting the device to the internet, and you're open to connect it, and that's why the cryptocurrencies are flourishing, right? Everyone are mining the cryptocurrencies on their machines. There's no one controlling them either. So Anupam also mentioned about governments realizing that what they lost, the lost opportunity. So that when the internet was invented and it started to come into the mainstream, the government were not interested in it, because they didn't actually, first of all, they didn't understand, what it was. They were heavily involved in the telephone network, and telephone networks were very well controlled. Even these days, it's all state controlled. But when it came to the internet in those early days, they actually didn't understand much, and they didn't anticipate that, the internet is going to be like this, now, how it is now. So it was a bit of a late entry for them into the internet. And so it's not that they can control now, even though they're trying their best. Some of the governments are trying their best to control it, but it's very difficult, because the way it got evolved and the way it is being used, it's very difficult to anyone to say, separate this AS1 network from the AS2 and AS3. Once you separate that network, then they are on their own. They're not talking to the rest of the world, right? You're segregating it, okay? And there are a lot of words to use that one, and you can see in the media, a lot of governments are trying to come up with things like that. Anyway, so that's the routers use send packets between each other, and also we have internet exchange points where the traffic stays locally. That actually helps the internet service providers to save money, cost on international bandwidth, as well as for us users, our internet cost goes down. If the operators use internet exchange points within the country, within the economy. So what happens is, usually in the early days of internet, if I want, sorry, if you're in Delhi and you want to send an email to say someone in Kolkata, and you may be connected to your ISP, maybe Bharti Airtel, and your friend's ISP in Chennai could be SIFI, right? Satyam Infocom. And you both are residing in India. You want to send from Delhi to Chennai. The way you do your snail mail. You write a postcard, you put it in the red box in Delhi, and it goes to Chennai within India, right? But whereas the internet, if say Bharti Airtel is not connected to SIFI in India and it's connected to elsewhere, say for example, it's connected to a provider in US, and SIFI is connected to a provider in Singapore. So what happens is, when you send that email from Delhi to Chennai, it actually goes to US and goes to Singapore and comes to Chennai to that user, to your friend. And there is a big cost associated with that international traffic, because the Bharti Airtel has to pay the US provider, for sending the package there. US provider has to pay to Singapore. Singapore has to then charge the Chennai, okay? But whereas if Bharti Airtel and SIFI, they're connected in India, then the packet just goes from Delhi to Chennai, and you can see there's quite a significant saving of the cost there. And this only happens with the protocol internet exchange point, where everyone connects to that point and everyone exchanges their traffic locally there. They don't send it outside of the country. It only happens. And this also helping, not only lowering the internet cost, but this also helping the content players to bring and put their content closer to where we are. That means it's helping with connecting fast, bringing the data across fast. So these days, you don't have to wait for even 10 minutes to load a website, YouTube, if you go to YouTube, you don't have to wait for 10, 15 minutes to load it, it loads instantly. Because Google, as a content provider, they're putting their Google cache or YouTube cache in Delhi or in Chennai, wherever this IXP is. Wherever the providers are connecting, they're putting it there. So the ISPs can access it directly from there instead of going to US and accessing from outside of India. That's internet exchange point. Resource public key infrastructure, or RPKI, is where we, if I go back here, is actually connecting these two routers securely. Okay, so hackers don't have a way to hack into this communication here. If it's open communication, anyone can hack this, right? So the way you protect this is through the RPKI, resource public key infrastructure, and with route origin authorization. So when APNIC delegates IP address to the providers, APNIC issues a certificate, digital certificate, saying that these resources belong to this provider. And that provider, that ISP, when they want to advertise those resources to the entire world, they have to attach that certificate to that resources, saying that I am authorized by APNIC to use these resources, and I am the custodian of these resources now to use to connect to the internet. And they have few classifications valid, that means whatever they're sending across the pipe, is all valid data or unknown or invalid. And this is how the routers, they look at the IP resources, they look at the ACE number and IP address, they compare the certificate, they compare with the APNIC database, and they validate. And if it's valid, they send the packet across. If it's unknown in the case, either the IP number is wrong or the AS number is wrong, or they can't find those, if it's wrong, then it's invalid, one of it is invalid. But if they can't fetch the data, they can't fetch the certificate, or they can't fetch those resources, then it's unknown, and they drop it. And these days, ISPs are actually dropping those packets, if it's not valid, they're not sending those across, to stop the hacking of the information. The other one is hyper transfer protocol secure, it's HTTPS. We all use websites these days, right? We all buy online, sell and buy online. And to do that, we have to enable a secure communication between the user and between the server and between your website, etc. So the hackers, again, don't interfere, don't attack that server, or don't attack that communication and take over your passwords and your credit card details, etc. So we use HTTPS. If you see any domain that's using HTTP, you should not visit that domain. Okay, I think these days the browsers are very smart enough to alert you that this is not a safe website, and it will give you options, you want to go visit it or not. And sometimes we say, no, yes, I want to visit it. You go into advanced options and you say, yes, I want to visit it. And then you're compromising your system. Maybe, who knows, what that website is hosting there. You may go and click some links on it, and that's it, your machine is compromised. And then you are helping the hacker, to propagate whatever they want to do. Whenever you visit a website, or whenever it shares a link with you, make sure it got S at the end of the HTTP. And these days, you can also validate the certificate of the website as well on your browser. Where the address bar is, you can see the green sign or the yellow sign or the red sign to validate whether it's a certified domain or not. Shradha, you want me to continue here, or you want to do this one? Okay, thank you. Domain names. So the last one, there are many protocols, okay, but these are the core protocols. We are going. Domain names we all know what a domain name is. We all probably have a domain name associated to us, like I got Chendi.net, that's my domain name. I registered that all my email IDs are, sunny@chendi.net, but sunny@apnic.net is my official one, work one. But what is domain name system? Again, going back, when the telephone system was invented, and when we all had telephones, even these days even though we were using mobile phones, we have a contact list in our phone, right? If you want to dial a number to someone, you open your phone book or contact list in your phone, and you look for the name, and and then dial the number. And the domain name system is the same. This domain name system actually have all the domain names that's registered in the world, and then their associated IP address. Okay, so if you want to visit www.apnic.net or Youth IGF website, you don't remember their IP address. What is the IP address of that? Because you can't remember all the IP addresses of every single website. But what you remember, or what is the name of that website. So you type in the name of the website, and then the server quickly looks into this domain name system and finds the IP address of that server, and then it will give you the information. So there's various systems involved in the domain name system, in the DNS. As you can see on the image here, there's a DNS resolver. DNS resolver is basically a stub DNS, which resides in our mobile phone or laptop or with our ISP. And what it does is it just keeps all the answers in it. It's not authoritative. It doesn't know everything of the internet, okay? But it only keeps what it's been asked, okay? So if you are asking for a domain name, youthigf.in, then it will take it and it will look in its files, and it sees if it got IP address. If it doesn't, then it will pass it to the nearest root server. Now, Anupam mentioned root servers in India, right? Now the root servers are everywhere. So it will go to the root server, and the root servers are the authoritative in the domain names. They know every IP address of every domain, but not to the end point. Okay, they only know the next level. So it works. The DNS works like a very much hierarchical system. So I'm a parent of my child, so I only know my child. Okay, I don't know my child's child. If you want to know, take authorization to talk to my child's child, who is my grandchild, you need to go and talk to my child, not to me. Okay, because my child is the authorized person to talk to his or her child. Okay, so it's very much hierarchical system. So the root servers in this case, if you say www.apnic.net, you want to visit, the root server will only give the answer to the .net part. Okay, it doesn't give the answer to www.apnic.net because it only knows .net. And the TLD server is what is top level domain name server. And all the top level domain names are, what are the top level domain names? .net, .com, .in. It's a CCTLD, country code domain name, but it's still a top level domain name. So now the TLD server only knows its children. Okay. And who is the children or child of TLD server? APNIC, right? In www.apnic.net, APNIC is the child of TLD server. The .net is authoritative now. Okay, it will tell you the IP address of apnic.net. Okay, and then it goes back, and then APNIC, the DNS resolver or the DNS server will send apnic.net server, what is the IP address of www.apnic.net. Now, apnic.net says, oh yeah, this is my web server. www is used for websites, right? So it's a web server, and here is the IP address. Okay, then that DNS resolver will save that information, and then it will pass to the device and says, okay, here is the IP address of the information you asked, www.apnic.net. Now you can go and get the data from apnic.net. So the information goes all the way to the server and fetches the APNIC website onto your device. So that's how it works. So the first iteration of you trying to query any website or sending an email, even sending an email also need to know IP address of that email ID, okay? And not just websites here. Any information that you're querying on internet has to have an IP address associated with it, okay? Usually the domain names have it. So the first iteration here is from your device to your service provider, okay? Sorry, from your device to your DNS resolver. And if it doesn't know the answer, it goes to your service provider, doesn't know, come back, root server, TLD server, the actual authority, whoever it is, and then it saves the information. Now, for example, if you have a friend working with you or connected to the same network here and asking the same information, say you have a friend and the friend also querying for www.apnic.net, then it will go to the DNS resolver. What happens here then? Does the DNS resolver provides that information to that device, or it will take all these iterations again? You can put it in chat. I'll just open my chat quickly. What happens here? Who will answer that device at a second time when the same website was queried? Anyone? Are you all sleeping or? Well, my co-speaker is saying resolver. Of course, yes, it is resolver, Yeah, so it's already saved in the resolver, right? So the resolver will pass that information to the device. But again, how long can the resolver keep that information, and how long that resolver can answer for that domain? There will be a value in that record. It's called a TTL, time to leave. It could be few days or few hours. So the DNS resolver can only respond as per the time limit. So if it's 1 day, within the 24 hours, the DNS will respond to any machines asking from that network, okay? After the 24 hours, the DNS resolver will drop that packet from, that information from it because it expired. So next time, if someone comes and asks that same information, it doesn't know where it is to go. So it has to take all the iterations again. Yeah. This is very critical and very important to understand. when you want to go to ICANN meetings and start engaging with their conferences or discussions, or even internet governance as well. So next one, and even with DNS, there's a lot of hacking happens at DNS level. A lot of websites get hacked, a lot of information get hacked. So we implemented DNS Sec, security protocol, securing the communication path between the DNS servers, like we secured the communication path between the routers with the rover, route origin authorization. In this case, it's DNS security. Every server have their security DNS keys enabled, and they exchange the keys to say they are the authorized of this information. So no one can interfere that information, or no one can hack in between that information. Okay. There's other protocols, file transfer protocols. We exchange files, we transfer files to each other. It's a very old protocol, but we still use it. Blockchain is a very new protocol. The cryptocurrencies, bitcoins, or even the banks have started using it. A lot of financial institutions started using blockchain. And also the RTP, for streaming, we watch a lot of Netflix, a lot of YouTube, and even this Zoom conference that we are talking to each other, it's all streaming the RTP protocol. We are using this protocol. Okay, so thanks for that. And I want to throw a question, what Haida said, if I remember it correctly, when she started engaging with internet governance, and she mentioned about culture and diversity. Internet provides culture and diversity, right? Are we there yet? Are we there yet? To have for the internet to provide that cultural diversity, especially the language diversity I'm focusing here on. Are we there yet? How many? I'll stop my presentation so I can see your chat. Are we there yet in internet helping us with the language diversity, or what's been achieved so far? That's one of the discussion point I like to bring it in from that earlier what Haida mentioned. And since we are in the internet governance session, this is something that we have to discuss on. We are building information. Okay, so the domain names primarily were in English, but now we can have international domain names, right? I hope you all know. Otherwise, Samiran will be coming in, I think, later in the session program. He'll be talking about it. So now we can also have a domain name within our own language. In that same the way we write our language, the script, we can have domain names in that language. There are also tools on the Google Translate, and there's a lot of other translation tools that can translate from English to our own languages, right? But we are still not there yet. For example, take this session here. I can well present my presentation in my own language, Telugu. I come from Hyderabad originally. I'm living in Australia, working for APNIC, but we are not there yet, right? I wanted to deliver this. I could deliver this in my language in Telugu, and you can listen to whatever your mother tongue is, right?
Just get it muted.
Sunny,
you're on mute.
You're on mute right now. Sunny, you're still on mute.
Am I on mute now?
Yes, we
can. Yeah. Sorry, I thought I don't know how it happened, but thanks so much. So where was I? I was talking about language diversity here, and I was explaining that we are not there yet in meeting the for internet to provide us that language diversity. What I was saying is now these days we can also have domain names in our own script, that we speak, we write. They are called international domain names, and you can register one in India these days. We also have Google translators. There's other translators that you can convert between different languages, the text. But when it comes to the actual speaking or listening part, with this presentation or with any presentations, I could well present this in my language, right? I'm from Hyderabad. I was born in Hyderabad. I speak Telugu. I can speak Hindi. I could have delivered it in Hindi or Telugu, and you could have listened in your own mother tongue, not in English, but so we are not there yet, we are not, there's a lot of research is happening. And also this is a good topic for internet governance as well, in terms of language diversity of internet governance. But I'll leave it there. I'm not sure what the time is. I think 12:15 was my time, 12:16. Okay, 1 minute over because I went on mute.
No problem, Sunny. We have 2 questions. Can we take those and then we can wrap up the session?
I will leave it for Shradha to answer. If you can, Shradha, try it, please.
Okay. So there's a question from Ronnie. Is there any type to make new rules for the internet to make the data that is stored in our system, and so that it conserves privacy? So are there any
100%? I'm going to give it to Sunny. Sunny will answer this question in the best possible way.
I will, and thanks, Shradha, but I quite didn't understand the question. Can that person please unmute yourself and talk?
Ronnie, please feel free to unmute.
Don't be shy, Sorry, I didn't understand. And I can answer, but I didn't understand that quite clearly. I need a bit more explanation on that question.
Ronnie, a request. Could you, will you be comfortable unmuting and asking the question? Okay, while he unmutes, maybe we can take another question. I think Devin had a question about asymmetric encryption in DNS Sec. Is that something that is being used? Devin, would you want to elaborate if required?
Various forms. DNS Sec is actually quite a lengthy topic, and various forms of encryption is being used. Currently, the encryption we are using is the public PKI, public key infrastructure and encryption. But I think it's a 128-bit encryption, I believe. It's but they are looking at increasing that, or they probably have already increased it. The technology always evolves. Today, I may saying, we are using 1024 or 1048-bit encryption, but in a week's time, you see that IETF comes up with a new design of the DNS Sec protocol, and they may suggest or recommend, using a much better encryption. So I would, for your question, Devin, and it's a great question, I would suggest you to jump on IETF website, and if after my presentation, I'll put the links as well in the chat if I can find that. But if you're really interested in DNS Sec part or DNS, the 2 places, you can get involved at APNIC conference, ICANN conferences, but the most importantly, it's IETF. That's where these get discussed, and they have a working group. You can join the working groups. This is the other thing. You don't need to be saying anything in the working group. You can simply join the working group, by subscription to the working group, and you can just see what's happening. What discussions happening. Again, I go back to what Haita said. Sometimes you just have to sit back and observe, just observe, what's happening, learn yourself, what's happening. And that way you can catch up with what happened before and to the current stage. And then you can start contributing, So I would strongly encourage you, Devin, to jump on IETF website, look for that working group, and I'll post it, if I can. But I'll leave it there. But as I said, the DNS Sec is a very lengthy topic, very, very lengthy topic.
So Sunny, could we take, do we have time for 2 more questions?
It's all up to you, Ahita. If you have time, I have time.
All right, then I think we'll take 2 questions. I'm really sorry, others. So
no, that's okay. I'm here.
Yeah, actually, so Sunny and Shradha will be there in the chat, so we can answer the question. We'll take 1 more, and then we can proceed with the announcement since we are heading towards lunch break.
I see.
I guess one person has raised the hand.
Yeah, let's take the people who raised hand as well, and we will get to the questions in the chat.
Sure. So, Parthajeet, please unmute yourself.
Yes, my question is that unlike India, where we had internet shutdowns, everything was shut down. But in case of China, when we take the case of Hong Kong, in Hong Kong, we get more or less good access to almost everything. But when we go towards the mainland, then a lot of things get restricted. Is it like, means how does that mechanism work? Is it like ABC websites can function, but the rest cannot? Or everything can function, but ABC cannot? And is there a viable way that something like that can be implemented in India for cybersecurity reasons?
Okay,
without infringing on freedom.
Now, good question and very much related to me. I traveled to China for APNIC conferences. We host conferences everywhere in Asia Pacific, and I stayed in the hotels there, and I wanted to access CNN website, and I got the website on my device, but it's not the real CNN website. Okay. It's mocked CNN website. So you may have heard, especially when it comes to China, you may have heard Great Firewall of China. Okay, so how it works is, again, it's very much state controlled over there. Being a communist state, I think they can do it, but it's not supposed to be happening. But the way it works is all the traffic is diverted to a DNS server. And that's called the Great Firewall of China. Every traffic, and there are people employed there, to actually mock international websites and put it on the locally there. So they literally copy the website of BBC, CNN, especially the media websites. And not so much like APNIC or Youth IGF India, not these kind of websites, but the major websites. They actually, what they do, they create this similarity of the same website locally, and they filter the information that they don't want their citizens to see. They only keep minimal information, looks like exactly like the main CNN website. And all the traffic that, no matter where you're in China, goes through your ISPs. It works the same, okay? It works same like how it was supposed to work here or anywhere else, but it doesn't go to the main root server or main DNS or main web server outside of China, okay? It goes to that big server within the China, and then the page gets served. And if you never visited the CNN or BBC, the actual websites, you probably think that is the legitimate website, and you probably start reading the information, and you will only see the information that they want to show you. You don't see anything else. So that's how it works. So they're filtering the traffic, everything through that big server there, and they're investing quite a lot over there on that one. I hope I answered your question. Now that same system is sort of extended to Hong Kong. Now the Hong Kong is very much in their domain, in their control, so it's extended to that one, Hong Kong, and all the traffic just pipes through one channel. There's a question. I have a question that who assigned domains? So who assigned domain names? There's various players. First of all, ICANN is the main body that manages the domain names. So if someone want to have a domain name, a new one that doesn't exist in the world yet, want to start a new domain name, they have to follow the ICANN policies and apply for ICANN to recognize the domain name, and there'll be long discussions, debates, and that's a true internet governance happens there. And once it's approved, then you start providing the domain name to others to use. Then you appoint, I forgot now, whether there's registry, registrars, and domain sellers like GoDaddy. You see, you actually buy from them. So you go and search on their website, and if it's available, you go and pay and buy the domain name from GoDaddy or people vendors like that, so I don't quite remember, but they have a structure. Registry, I think, registry, registrar, and retailers. Registrant. Sorry, registry, registrar, registrant. Registrant are the ones we register the domain name. I hope I got it right. But you can ask that question to Samiran when he comes online.
Yes.
He works for
Arpanet. Thank you, Sunny. Thanks, Shradha. There are a lot of questions and very interesting ones in the chat. So I would really request you to take the questions and answer them for our delegates over in the chat. Right. So I would first of all like to thank Sunny. Thank you for this brilliant idea to bring our alumni Shradha on board for this presentation. Yes. Shradha, very impressive presentation. See, most of the time when we talk about the internet infrastructure, or discuss how routing takes place, all the concepts around BGP and all that, I'm very happy that you handled it so well, and then you made it so simple for people to understand, and irrespective of their educational, professional backgrounds, and you got them motivated. So I'm very, very happy, and I'm very proud to say that you've been a Youth IGF and APNIC alumni as well. So good job at that. Sunny sir, as usual, thank you very much for this very interactive and engaging session. This topic is very interesting, and I have been personally, I've been learning this topic since I think my first time at EPIGA, I think in Korea. And after which at Youth IGF, every year we make sure that this interesting topic is discussed, and also at the India School of Internet Governance. And every time, like Shradha mentioned, there is something new that I get to learn. So thank you, sir. And thank you, Shradha.
Yeah. No, thank you, Ahita. Just want to say that Shradha already mentioned about the IP Go game, and I think you, Ahita, you experienced that IP Go game at EPIGA. That's how you learned how internet works. This is for the virtual format of events, this presentation, but we usually don't use this presentation, full-fledged presentation for a physical format. We actually have IP Go game, and it's like playing Monopoly or playing any board game, and we actually play that game to make you learn how internet works through that game. Maybe in the future events, we'll come back with the game, but we, as Shradha mentioned, we are actually developing the online version of it to use it for the online conferences. Thanks, Ahita, once again inviting me, inviting APNIC, and thank you so much, Shradha, for I hope others take inspiration from Shradha and become co-speakers in the next event. Thank you so much.
Thank you so much, Sunny, for giving me the opportunity, and Ahita for inviting me. So this is what you're looking at if you continue participating in internet governance domain. Like, learn from IGF, learn from Ahita. Ahita knows a lot about how to get really interested and how to understand the field. Sunny will give you all the technical information that you need. Any doubt you have, you just text or email Sunny and he will reply almost immediately. And everyone else in this field is very welcoming. So it's just up to you about how much opportunities you want to take up, and you take up, and everyone will help you out at every level. So it'll be great if you continue participating in IGF. And after IGF, take like bigger steps. There is the Asia Pacific region version. There is the Korea version, the APIGA that happens. And then there is the big event, the IGF, that is currently under process, and it's going on right now. So if you want, you can just jump on the YouTube page, watch a couple of videos, don't understand it, close it, keep it aside, but then go back to it again after a week or two. So that's how you learn, that's how you grow. It'll be great.
Thanks a lot, Shradha, for the motivation. Yes, so we have a lot of other opportunities, and we have a session planned today itself in the second half, where we have youth speakers from the other platforms and other organizations that are working on capacity building. So there are going to be tons of opportunities discussed there. So now we've come to the conclusion of the first half of the day. We started off with learning. We had, I gave a welcome note, and then we had Sudha ma'am talk about, welcoming everyone to the annual forum, the 4th edition of Youth IGF. And then we had Miss Anya talking about internet governance, the role of youth in IGF, and also the upcoming edition. Then we had Miss Amrita and Mr. Anupam talk about what internet governance is, what is the essence, who are the stakeholders, what does the ecosystem of IG look like, and where youth come into play here. Then we had the super interesting session by Mr. Sunny and Shradha, where we